Hi, everyone. Thank you for joining this session. Right now, we're going to be hearing from Beverly West from CODEE, and they're going to give their talk sharing news and offerings of CODEE. So I'll hand it over to Beverly, and if you need anything, just let me know.
Okay, it was wonderful to be part of another great expo. I want to give heartfelt thanks to Brian and to CODEE, our partner, in constantly encouraging and improving the teaching and learning of differential equations. So I will start with a very brief history, but I'm trying to do this sort of in the order of time that these things happened. Before there was the internet, as we know it today, it was a very different time. 31 years ago in 1992, Bob Beverly and Courtney Coleman from Harvey Mudd launched CODEE, the Consortium for Differential Equations Experiments. With the first of 3 NSF grants, they brought us together from 7 different institutions. You see them listed: Harvey Mudd, Cornell, RPI, Washington State, St. Olaf, West Valley Community College, and Stetson University. And we were all harnessing the recent availability of computer graphics to make the study of differential equations so much more powerful. Over the first 4 years of this grant, each of those 7 institutions held a week-long summer workshop at their schools, each one for 30 colleagues from all over the United States. And we also ran for many years sessions and workshops at JMM and other meetings, and produced a newsletter and paper to spread news of this revolution and to help colleagues and their institutions overcome inertia and adjust to accessing this new power for solving DEs, to be able to see behaviors, even for the majority of differential equations that do not have analytic solutions. As you, but not everyone, already knows, this enormously helps studying real-world systems. John Hubbard, who was one of the early pioneers, told me just 2 days ago he thinks we failed, that many ODE courses are still being taught without computer graphics. But with CODEE and CODEE, I really can dispute that. However, in my experience, I know it can happen, especially when colleagues in other mathematical specialties who may have to teach a DE course in a load of 3 or 4 other courses a semester, they don't have time to go beyond the traditional syllabus, which has been out of date since the 1990s. Their students completely miss the power computer graphics brings to differential equations. Whoops. Our second grant, the CODEE members worked together to create a software package called ODE Architect. It had motivational videos, strong platform for exploration, a companion book with lots of labs and projects, and it spanned everything from simple differential equations to chaos. It was published by Wiley and won an amazing award from Forbes magazine as one of the 9 best software projects on the planet in 1998. And we were the only one in mathematics. We were alongside X-Files, Ceremony of Innocence, Hot Pot, L'Afrique Sauvage, DroidWorks, the Apple Store, Mercedes A-Class, and MediaBoy.net. That gives you a little flashback to signs of the times. But software doesn't last, and as we all know, as operating systems evolved, many of these early graphic software packages that had been designed specifically for differential equations, including ODE Architect, became obsolete. We're currently updating our resources page on the CODEE website, particularly the software resources section. So we started by surveying our editorial board and asking what software they used in their ODE courses. More than half the respondents said Maple, Mathematica, or MATLAB as their primary course resource because their schools subscribe and their students were familiar. But many dedicated differential equations packages were also listed, for demos, students used for homework and so forth. But there are several favorites that are written in Java, and they may need help to run. So I'm going to talk briefly about them and then newer programs. We have learned of a fix that allows Java applets to run. It's called ChirpJ Applet Runner to Chrome, but you've already seen how clumsy I am with computers. I haven't been able to get it to work, and I can't write a simple explanation. If anyone can do that, please let us know and we'll add it. The things we would like to be able to run that are very favorites for many people, dfield and pplane. Shortly after our workshop in 1992, John Polking of Rice wrote these two things as add-ons to MATLAB, and then later he made them into Java standalone applets. And either way, they became very popular. At that time, in 1992, it was revolutionary to choose an initial condition by clicking on the graph instead of typing values in a box. I had to shout into the phone to the people developing ODE Architect. They didn't get it. They're so used to typing things in boxes, and we couldn't stand that. We got them to do it right. There's another program that's not a solver for any differential equation, but is a set of more than 90 interactive illustrations that allows students to explore concepts and learn them without realizing they're learning anything. I mean, it's better than a lecture. This particular early one is showing y squared minus x, y prime equals y squared minus x. It's actually y squared minus ay minus x, but if you set a to 0, that's what this particular one did. The slider on the bottom lets you make that setting. The sliding on the top is for the slopes that will draw yellow lines. And then students just clicking anywhere can see the turquoise solutions evolve and follow those isoclines exactly as directed. And before we had this computer graphics capability in general, no matter how much we lectured about solutions have to follow the direction field, there were many exams where the students did not do that. And the first exam that we gave after this, every paper was correct. So we know it's a good thing, and it's an example of how good it is to have them play around. But new software has emerged. 2 packages are designed specifically for mobile devices. They're very popular with students. They're often used in class for demonstrations. The first one is by Daryl Nestor, Bluffton University, slope and direction fields. Remember, it's made to work on a mobile device, and he can make good use of colors. And the second one is by Tim Lucas and his students at Pepperdine. You're going to have a nice demo today by Tim at 4:30. And this is, the only picture I could give to give you a clue of what's ahead. For a much bigger workhorse, we have a nice computer-based set of GeoGebra-based visualizations by Paul Seeberger at Monroe Community College. He uses his own programs for Direction Field Explorer and CalcPlot 3D. You can access this just by Googling Paul and his website. So we had a wonderful talk and demo at the joint math meetings, and I highly recommend it. By now, it's 2007, and the internet is truly available. I remember very clearly at one of our early CODEE meetings in probably '94, when Bob Beverly had students trying to demo to us this thing called the World Wide Web. And it took a while to be readily available, but it is. And so Beverly and Daryl Young at Harvey Mudd with Amy Rodenskaya at Pomona, they created a free online open access CODEE journal using the Claremont College libraries, who use bPress for publishing. bPress started at Berkeley. It is a publishing system that they wanted to make it easier for scientists, and it's somewhat automated. They also publish several other journals, including the Journal of Humanistic Mathematics. So they have a set routine, and it works quite well. At this time, our name changed and became a community of ordinary differential equations educators. And we published the first issue in 2009 as volume 7. And so you wonder where are volumes 1 through 6? Well, they're under the resources. They're digitized versions of those paper newsletters from 1992 to 98. From the very beginning, the CODEE journal has been downloaded all over the world. This is a typical homepage of the bPress journals. You may need to scroll down to see it. It's an active thing, and every few seconds another dot gets put on the map, and the text above tells you the city, state, and country. This was recent download, 179 out of 197 in the past week, and that's typical. It's always changing. And this particular paper was integrating factors and repeated roots of the characteristic equation by Howard Dwyer and William Green, being downloaded in Rwanda. So we've gotten pretty excited, at least I have, at how it goes all over the world. This is a static map showing number of downloads from the beginning in 2009 to December of 2022. And the little blue circles are for single-digit numbers of downloads. Purple are double-digit, yellow are triple-digit, green are 4 digits, and those 2 big orange circles are 5-digit numbers of downloads. You can see that in the US, that gets added to a couple of other circles. In Europe, the same way, you can add to another few circles. And in the US, I end up with 16,000 downloads, Europe 15,000, Asia, especially Southeast Asia, Mexico and South America, Mideast, Africa, Australia, Southern Pacific, and others. So that's roughly 1/3, 2/3, 3/3. Sorry, that little, oh dear. All right. Every time I run this, something moves. Every single article that's published in the CODEE journal from 2009 to 2023 is still being downloaded. They don't go out of date. It's amazing. Surely that says something about the long-term relevance of these papers as a valuable resource to folk all over the world. Downloads are recorded in 167 so far out of 195 countries. This global outreach shows we're fulfilling a special mission. It's been good to focus on that. I'm sorry about this one, but this is why I have my paper copies by my side. CODEE was delighted in 2013 or so when Semiote began, because they took over the workshops and sessions that attract the enthusiasm of younger colleagues, as CODEE's original mission did. In addition, Semiote has added a blog, competitions, expos, etc., taking full advantage of the internet, where data is now hugely available. So this is an amazing new world we have to work in. The last time I looked at this, that first paragraph was not garbled. Okay. Now CODEE concentrates on the journal. We don't have any funding, so we are entirely doing what we can manage with volunteers. And here are a few of the articles that have not gone out of date. The top winner at the moment is climate change using bifurcation diagrams. And that was part of our special issue in 2019. It has over 4,000 downloads. Teaching an online sophomore course with Mathematica supplements by Bill Kenny was top for a while until climate change eclipsed it. Modeling the effects of avian flu. I noticed there's a talk further on our schedule for this expo, which I presume will carry that further. Epidemiology in the SIR model in historical context, from original sources to what's going on today. The mathematics of gossip is downloaded in the most amazing places all over the world, very popular. SIR models, differential equations that support the common good, is a wonderful collection by Laura Lee Koss, whom you're going to hear this afternoon. And then we have Cholera by Therese Shelton and friends. Kremer's model relating population growth to changes in income and technology by Dan Flath. This we love because shortly after, like a year and a half after this was published, Kremer won the Nobel Prize. So we scooped him. Scoop Nobel. Okay. Then an epidemiological approach to a political system with three parties is another very popular one. Extending power series methods for Hodgkin-Huxley equations. Qualitative analysis of resource management and what it means for whale populations by Glenn Letter. You're going to hear from him in this Eco Expo. And then maintaining ecosystem and economic structure in a three-species dynamical system in the Chesapeake Bay. This is a recent article, volume 15, currently up on the website by Myla Halari, who you just heard, and Yordanka Panayotova. We also started special issues. The first was in 2019, linking differential equations to social justice and environmental concerns. It was very successful and really ramped up the number of downloads. It's an exponential growth curve as we've started these special issues, which were a project of Karen Keene when she was our editor-in-chief. Then the second one in 2021 was engaging learners for differential equations in today's world. That didn't have so many papers because of COVID. Everyone was too busy changing everything. But they're good papers, and we're just launching a third, which is Engaging the World, Differential Equations Influence Public Policy. And it's edited again by Samar Haber of the Lebanese American University in Beirut. He loves being able to continue this. It's one thing that helps him keep sane in the chaos in Lebanon. Short proposals are due in just a couple of weeks, and we're hoping that some of the CODEE people can contribute. I have my eyes on two that are coming up. One is Advait Sridhar and Peter Zhu on the bird flu H5N1, and another is Victor Donnet on community-based projects. So I hope that some people can consider entering something for the special issue. There's a little motivation. One of my favorites was from the second special issue by Chinenya Afodali at Albany State University in Albany, Georgia. And he attacked that question in the context of his course labeled, the talk I heard in 2020 was engaging students early by internationalizing the undergraduate calculus course. And I spoke to him afterwards and said, so how many of those involved differential equations? And the answer was all of them, because they were at the end of their calculus course getting to y prime equals ky. And Chinenya's, his students chose from a list of suggested topics all over the map. You really should read the article. And gather data, and then when they reached that differential equation, they were able to graph and predict future growth or decay. And then Chinenya's genius was to have them suggest solutions to projected problems. So some of the choices had involved local issues, such as crime or HIV in their own county. And the students planned to take their research and suggestions to local authorities. But unfortunately, the pandemic and bureaucratic runaround delayed this objective until the students had moved on with their lives, some even graduated. So we have no results on that. It's a caution for student projects, but it doesn't mean you can't talk about them. So don't hesitate just because you might not have gotten to the end. And you will be overjoyed to see that I'm done. We provide a wealth of materials on our website, which is simply CODEE.org. The resources, in addition to articles, are in the process of being updated right now. If you want a list of all the articles, email either me or Mila, who's our competent new editor-in-chief. And we look very much forward to continuing our symbiosis with CODEE. Thank you.
That was great, Beverly. Thank you.
Thank you.
Thank you so
Sorry,
much for that talk. No, you did amazing. We have time for a couple questions if anyone wants to, but thank you again to Beverly. This was an amazing talk.
You mentioned the special issue, and you said the deadline is February the 28th.
Oh, that's just for a very short proposal.
Okay, so we're
And
looking
at that point, we look to see, what's fitting into our topic and what we think should proceed. And you'll know quite quickly what's accepted. And then by the end of March, and the papers aren't due till June.
So can I ask just a little, so are we looking in particular about the novelty of the model, or we want to talk about something like ways of teaching in the classroom, like which particular
I think what we're tending to focus on this time is the possibility of taking the topic out of the classroom and going further with it.
Okay, thank you very much.
Things like Chinenya's paper are a good model, and Mila and Yordanka, they've got 2 papers on the Chesapeake in the CODEE journal. And when they sent the first one, they decided that the idea of taking this outside the classroom and going further with it would have to wait for a second paper. And so that's what their second paper is working toward.
Thank you. I find the paper on your website. I will look into that. Thank you very much.
Okay, thank you.
And I'll say CODEE is great to work with. They really get, the editorial staff gets back with you and makes suggestions. And I was fortunate enough to have Beverly as one of my, main editors, and her, discussion with me made the paper so much better. So I really
But it was a
appreciate the
good
work.
paper to begin with.
Yeah, well, thank you, but you made it better.
Okay, thanks. We enjoyed that. That's fun. That's why I've resigned from everything else, but I still want to edit these papers because they're so interesting.
She's a great editor.
Okay, that will conclude this room for today. I hope you all enjoy the rest of the conference, and I hope that the next talk goes well. Thank you all for coming.
Thank you.